Today we are going to be looking at section 11.1, solving quadratic equations by completing the square. To begin with, on example 1, it says use the square root property to solve. So that means we're going to take the square root of both sides of this equation, x squared equals 50. The square root of x squared is x. And the square root of 50 is plus or minus the square root of 50. Now 50 breaks down to 25 times 2. We know 25 is a perfect square, so we can take 5 out because 5 times 5 is 25. So our answer ends up being x equals plus or minus 5 times the square root of 2. On our second example, we're still asked to use the square root property. So we're given 2x squared equals 14. We can divide both sides by 2 and we get x squared equals 7. Then taking the square root of both sides, we get x equals plus or minus the square root of 7. On example 3, we're still using the square root property. And we're given the equation, the quantity x plus 1 squared equals 12. Taking the square root of both sides, we get x plus 1 equals plus or minus the square root of 12. 12 breaks down to 4 times 3, and since 4 is a perfect square, we can take 2 out. So now we are at x plus 1 equals plus or minus 2 times the square root of 3. Then we subtract 1 to both sides, and we end up that x equals a negative 1 plus or minus 2 times the square root of 3. Going on and still using the square root property, on example 4, we're given 2x minus 5 squared equals a negative 16. Taking the square root of both sides, we get 2x minus 5 equals plus or minus the square root of a negative 16. We know that a negative 1, the square root of negative 1, is I, and we know the square root of 16 is 4. So we have 2x minus 5 equals plus or minus 4i. Taking the 5 over to the other side, we find that 2x equals 5 plus or minus 4i. Then dividing by 2 to isolate x, we get x equals 5 plus or minus 4i divided by 2. On example 5, they kind of switch gears a little bit, but they talk about completing the square. When we complete the square, we make the quadratic a perfect square. So let's do it. First of all, we look at the coefficient of p, better known to us as b. So anyway, it is 2. You always take 1/2 of the coefficient of the variable. 1/2 times 2 equals 1, and then you always square it. So 1 squared is still 1. So then we add 1 to both sides of the equation. What that does is makes the left part of the equation a perfect square. And sure enough, it is the quantity p plus 1 squared. On the right side of the equation, we also had to add 1 to keep everything equal. So we have 4 plus 1 equals 5. Now we take the square root of both sides of the equation, and we find that p plus 1 equals plus or minus the square root of 5. Moving the 1 over to the right side of the equation, we find our final answer, which is p equals a negative 1 plus or minus the square root of 5. On example 6, we have the equation m squared minus 7m minus 1 equals 0. And they tell us to solve it by completing the square. We do the same thing like we had on the previous example. We take the coefficient of just the variable, and it's always the b. So in the middle term, this one, so we have -7. -7 is the coefficient in front of m. We take 1/2 of it, which is -7/2. Then we're always squaring that, and when we do that, we get 49/4. So we add 49/4 to both sides of the equation. And here it is, m squared minus 7m plus 49/4. What we do to one side of the equation, we have to do to the other. So on the right side, we are also adding 49/4. Excuse me. So it ends up being that m minus 7/2 squared, there's our perfect square, equals 53 divided by 4. Taking the square root of both sides, we find that m minus 7/2 equals plus or minus the square root of 53 divided by 4. Taking the 7/2 from the left side to the right side of the equation by adding 7/2 to both sides, we find that m equals 7/2 plus or minus the square root of 53 over 4. Well, we know here in the denominator, the square root of 4 is 2. So we go ahead and continue simplifying, and we get 7/2 plus or minus the square root of 53 over 2. Since both of them are over 2, we can write our answer as m equals 7 plus or minus the square root of 53, all divided by 2. On example 7, we have a new formula, and it's a compound interest formula, where the amount equals P times the quantity 1 plus R, all raised to the T, where A is the amount and P is the principal, and R is the rate, and T is time. Find the interest rate if $2,000 compounded annually grows to $24.20 in 2 years. So we simply plug in what we know. We know the amount is $2,420. We know our principal was $2,000. And we're trying to solve for our rate. So we end up dividing by 2,000 to both sides, and we get 2,420 divided by 2,000 equals 1 plus R, the quantity, squared. Reducing 2,420 divided by 2,000 to 121 divided by 100, we still have that equaling the quantity 1 plus R squared. So we're going to take the square root of both sides, and we get the square root of 121 divided by 100, and it equals 1 plus R. When we look at the 121 over 100, we see that they're both perfect roots. So now we have the answer of plus or minus 11 divided by 10 equaling 1 plus R. Moving 1 to the other side, we get -1 plus or minus 11 tenths equals R. Now if we go the top route and do a -1 plus 11 tenths, we get R equals 1/10. If we do the bottom route, we have a -1 minus 11 over 10, and we find that it would be a -21/10. We throw the second one out because we can't have a negative rate. That does not make sense. So our rate for sure is 1/10.